Hello students. So today we will discuss gravitation chapter, advanced previous year questions. So here first question is given. This is 2013 advance. Two bodies each of mass m are kept fixed with a separation 2l. A particle of mass m is projected from the midpoint of the line joining their centers perpendicular to the line. The gravitation constant is g. The correct statement means here a required data they have given in the question already, so we need to match with the given options. Let us draw the diagram for the given corresponding question. So two particles are separated by certain distance, they said. So let us take each particle mass. Two bodies means two particles are considered here. Two particles mass is given. First particle mass mentioned as capital M, and second one is also having same mass. Mass of the particles is same, right? And both are separated by a distance 2l. So distance between both the particles is given as 2l in the question. So let us take this distance is 2l. And here a particle of mass m is projected from the midpoint of the line joining their centers. Between these two particles, a small particle, another particle has projected from the midpoint. Okay. So this particle has projected with certain velocity. We are projecting means minimum velocity we have to give, so that its velocity is v and particle mass is small m mentioned. Okay. Next, the minimum velocity of the mass m to escape the gravitational field of both the bodies. Achha. This question related to like escape velocity. Generally, to project any particle into space, what we need to give? So minimum velocity we have to give, escape velocity we have to give, right? So here also there are two particles are given, masses are m, and one particle we are projecting with certain velocity v and mass of the particle is small m. What should be the minimum velocity we have to give to this particle so that it will escape from the gravitational field of both the given objects? So how much is the minimum velocity we need to give? To solve this question, we need to use energy conservation method. If you apply daily life, the same concept, example, rocket launching case, definitely air friction is present. In that case, we cannot make energy conservation because due to air friction, some energy loss is there. But here assumption they have given, there is no loss of energy we can consider, so that initial energy should be equals to final energy. So we'll use the equation, initial energy of the system should be equals to final energy of the system. Initial total, what is the energy, initial energy of this particle we can write. We are giving some velocity, that means we are giving kinetic energy also. So particle has kinetic energy, how much we can write kinetic energy? Half mv square is the kinetic energy of the particle. And what is the potential energy between these two particles? Potential energy we can write minus g m into small m divided by distance between these two. Total length is 2l given, right? That means what is the distance between one particle and the midpoint? L. Similarly, distance between the particle and the other mass, this length is also L. Here length is L, this is also length L. So we can write this total equation as minus G into M divided by L, which equals to, what is the final energy if it escaped the gravitational field? That means it entered into the outer space. That means final energy becomes 0 here. There is no final energy to the particle. So it's just to take these two negative terms right side and rewrite the equation so that this becomes half mv square equals to, loose connection is there or not? Let me check. So it seems to be vibrating, that's why. So half mv square equals to, this becomes 2 into g m into small m divided by L, right? So small m and small m gets cancelled here, and v square can be written as 4 times of g into m divided by L. Here mass values gets cancelled and v square can be written as 4gm divided by L, so that v equals to square root of 4gm divided by L. So that final answer is root over 2gm divided by L. This should be the answer. So 2 root gm by L. Verify here the options. First option given as a 4 root gm by L. No, first one is wrong. This is not the minimum velocity. So minimum velocity 2 root gm by L we got. Minimum velocity to escape 2 root gm by L. Right. Option should be B. Option C is wrong. Option D. The energy of the mass m remains constant. Yes, energy remains constant. That's why we can apply here conservation of energy equation. Initial energy equals to final energy we can write, because here energy is conserved. So option D is also correct. Here multiple answers correct question it is. Statements is are true they have asked. Right. So this is based on basically conservation of energy concept only and very similar to that of derivation of escape velocity. So this is 13th question. Next one is 2015. So I hope you can see this question very clearly. Just a minute. If you want, I'll zoom this one. Right. So 2015 question it is. A bullet is fired vertically upwards with velocity v from the surface of a spherical planet. Okay. When it reaches its maximum height, its acceleration due to the planet's gravity is 1/4 of its value of the surface of the planet. Understanding language of the question is very important. If the escape velocity of the planet is v escape equals to v times of root n, then the value of n is, ignore loss due to atmosphere, means again air friction we are not considering here. Daily life is different. Air friction we cannot neglect, right? Here neglect the air friction, that means energy conservations whatever we can apply, all the conditions we can take. Okay. So how to solve this question? Let us take the condition here. As per the given question, they said that acceleration due to gravity at certain height h equation is g divided by 1 plus h by r whole square. This is the equation we can write. Acceleration due to gravity at certain height has a different equations. We can choose any equation, but I am taking this equation here. Acceleration due to gravity at certain height given already in the question itself. How much it is? 1/4. So I write this equation as g by 4, which equals to g 1 plus h by r whole square. Here g value and g value gets cancelled. So 1 plus h by r can be written as 4. So from this h by r value becomes 3. This becomes 1 plus h by r whole square, and this is 4. So h by r value if I write, this becomes 2 minus square I am removing. So h by r only, so 4 minus 1, and this becomes a square if I remove. So 2 minus 1, this becomes as 1. That means h value equals to r. Hope I have written directly here. H value becomes r. You just simplify, you will get same answer. H equals to r. That means from the surface of the planet, if you go to h height, the gravity becomes g by 4. If I take the corresponding diagram, let us take, there is a planet, a spherical planet is there, and its a radius. Let us assume that its a radius is r from the center. So I will take here radius of the given planet from the center to here, its radius is r. Now at what height the gravity became g by 4th as per the question? At a height of, after simplifying we got h value r. That means from the surface of the planet, if you go to r distance, then g value became g by 4 at this height. Gravity at this height became g by 4. Now this h value, what is this h value? We got nothing but radius of the planet only. Now we need to find out what is the relation between the escape velocity and the velocity what we have thrown. The particle has thrown from this point. From here we have thrown with certain velocity v, so that this particle has reached a maximum height. This is nothing but the maximum height attained by the particle. At maximum height, final velocity becomes 0, that we know. Okay. Now escape velocity and projected velocity we need to relate. So what is the escape velocity formula? Escape velocity equation can be written as root over 2 gm divided by r. This is escape velocity equation. Now how to get this velocity? With what velocity we have projected? We can use energy conservation equation. What is the initial energy of the planet? What is the final energy of the planet? If the particle is on the planet, it has kinetic energy because we are throwing with certain velocity, so kinetic energy is there. And on the surface of the planet, every object has potential energy also. So here we can write again energy conservation equation, that is initial energy should be equals to final energy. This is the reason they mentioned in the question itself. Do not consider any energy loss because there is no loss of energy. This is the assumption. So initial energy equals to half mv square minus potential energy equation is gm into small m divided by r equals to, what is the final energy? This is maximum height. At maximum height, final velocity of the particle becomes 0. But potential energy is there at the maximum height. So what is the total interaction energy? Total potential energy is minus g into capital M into small m divided by total distance. How much? From the center of the earth to maximum height, total distance is 2r in this question. So we can write here total energy is minus g m into small m divided by total distance is 2r. Here I repeat this point. Particle is on the surface, so here we can write potential energy, initial potential energy equals to minus g into planet mass into particle mass divided by initial distance from the center to the particle is r. This is point. Final potential energy, what is the final potential energy? That is again g into mass of the planet into mass of the particle divided by total distance from here to here. What is the total distance finally? R plus r. So its value is 2r. That's why final potential energy I have taken 2r. Distance is 2r. Here 2r I have mentioned. Okay. Now we need to get here r value. If you observe this equation, small m gets cancelled. Now find out v value. So v square by 2 equals to, bring this negative term right side, this becomes gm by r minus gm by 2r. I'll multiply this equation with 2, divide with 2. So this becomes v square by 2 equals to gm divided by 2r. The 2 value gets cancelled. So v equals to under root gm divided by r. This is velocity of the particle. This much velocity we have thrown the given particle. How to relate this one and escape velocity? We can relate escape velocity equals to square root of 2 into gm divided by r. So in this equation, instead of gm, what we can substitute? Instead of root over gm, we can substitute small v. So therefore escape velocity equals to root 2 times of given velocity. In the question they are asking ve equals to root n times of v. Then what is the n value they are asking? Just to compare these two so that we can write n value should be equals to here. Before watching this solution of these questions, first pause the video and you just try by yourself. This is first thing you have to do. Second thing, before solving all these questions, just to 10 to 15 minutes quickly revise the gravitation chapter notes, so that formulas you can remember and you can apply those formulas to the given questions. Okay. Next question. This is 2015. This is also a very good question, and a little bit knowledge of laws of motion is also required. See the question here. A large spherical mass m is fixed at one position and two identical point masses m are kept on a line passing through the center of mass n. The point masses are connected by a rigid massless rod of length L, and this assembly is free to move along the line connecting them. All three masses interact only through their mutual gravitational interaction. When the point mass nearer to m is at a distance r equals to 3L, this is important, r equals to 3L from m, the tension in the rod is 0 for m equals to this much, then the value of K is. So in this question, entire given data is very clear and we need to get what is the K value. Okay. Condition is what? Tension in the rod should be equals to 0. This is the condition as per the given question. Okay. Just to draw the simple diagram here. Let us take, there is a spherical object. Its mass is given as capital M, and this is center, and here two particles are also arranged along the given line. So let us consider this is the first particle, mass is small m, and this is second particle, its mass is also small m. Right, one is having a spherical object, mass given as capital M, and the remaining two are particle masses only, masses are same, small m they have given. From here to here, this distance is given as, from the center of the spherical object to the first particle, the distance is given as 3L, because R value mentioned as 3L. Distance between both the particles in the question they mentioned as L. Right. Now these two particles basically connected with help of a rod, and rod is massless. There is no mass for the given rod which connected between the particles. Right. Now identify how many forces are acting on small m's. Which force is responsible for the acceleration of the system? So all those we need to identify. First to see this small particle here. Capital M, this spherical body wants to attract this particle mass towards its side. Gravitational force is always attractive in nature, right? So this capital M wants to attract the small particle towards its side. So this is, let us take this force I am writing as F, and this is small m, whatever the small m is there here, this small m wants to attract this particle, right? So what is the direction of attraction we can represent? This particle wants to attract this one towards its side. This force I am writing as F1. Okay. Now if right side particle wants to attract the left side particle, then left side particle also wants to attract the right side. Action reaction forces. So the force between small masses is F1 F1. Here understand the point here. The midpoint, whatever the midpoint is there here, this is the midpoint. It is experiencing two forces. What are those two forces? One is the force applied by left side force is due to capital M, right side force is due to small m. Next one, observe the last particle. On the last particle, how many forces are acting? Again two forces are acting. Whatever the force I have represented F1, this is the force applied by this small particle. And another force also acts. What is that another force acts here? Another force is force due to spherical object. This spherical object wants to attract this. Let us take its force is F2. Here I will write the terms also. F1 is force between small particles. Two particles are there, both wants to attract each other, that is the force I have represented with F1. F1 is acting both on the small particles. Next, capital F. Capital F is force between capital M and near mass, that is small m. Next, F2 value. F2 means force between capital M and far mass small m. Hope it is clear to you now. Okay, these are the terms we represented. Now, as per the condition, there should not be any tension in the rod, because these two particles, whatever the particles are given, small particles, these two particles are connected with help of a rod, massless rod. So tension value should be 0, means definitely these two particles, both the small particles here, this is one small particle, this is one small particle, these two particles should move with constant acceleration. Its acceleration A means it also moves with an acceleration E. Then only tension value becomes 0. Clear? I redraw this entire diagram here. This is the given a spherical object. Spherical object is given. This is the center to the different particles. It is having mass capital M, and this is small particle given small m is mass. This is another particle small m. Now these two are connected with help of a rod. Small m, this is moving left side with an acceleration A, this is also moving left side with an acceleration A. Both are moving constant acceleration. You see this pen, one end one particle is there, other end another particle is there. Tension should be 0 in this entire rod, means whatever the particles are connected at both the ends, both are moving with a constant acceleration only. They have to move with the same acceleration, then only no tension developed in the given string. Otherwise there is a tension developed, but as per the given question, tension should be 0. That means there is no doubt both the particles should move with the same acceleration in the same direction. So accelerations both A I have taken, mass is given, everything is mentioned. Right. Now equation would write what are the forces are acting on this we have taken. One is the force acting F, other force acting is F1 we have taken. Okay. On this particle, what is the force acting? F1 is acting, as well as on this particle another force also acting, that is F2. Now write the equations. For the first particle free body diagram, first particle I am applying Newton's law application, free body diagram application. So it is moving. This is the first particle. Right side is F1, left side is F. Particle mass is m. Its acceleration is a. Already you know how to write Newton's law equation. So directly you can write F minus F1, net force equals to mass into acceleration. This is equation number 1. Clear? Similarly, second particle, this is the second particle we have taken. On the second particle, both the forces are acting right side only. F1 is acting, F2 also acting. Both are acting same direction, so I have added. What is the acceleration of this mass? Its acceleration is also A. So how to write second equation? That is F1 plus F2 equals to ma. Why here addition? Because both the forces are acting in same direction. In the first case, both the forces are acting opposite direction, so we need to subtract. Now add equation 1 and 2. If you add equation 1 and 2, minus F1 plus F1 gets cancelled. So what left? F plus F2. F plus F2 equals to ma. This is the equation we got. Right? If I add equation 1 and 2, so that F plus F2 equals to m into A. Acha, m into A, m into A, this becomes 2ma. Okay. So 2 MA is the total force acting. Now what is the F value, what is the F2 value? How to represent this F value and F2 value? For that we need to apply again the rule, means whatever the distances are given, Newton's law of gravitation we need to apply. F value we want, so from here to here I will write distance given 3L, and F2 we want, F2 means here to here, total distance becomes 3L plus L 4L. Okay. So F is acting as well as F2 is also acting. Now what is the F value? F is the force between, we have seen that F is the force between this particle small m and capital M. Question becomes a tough, okay, not a very simple question. That is why advanced questions I am dealing. In the class, if I explain all this, one question takes almost half an hour. Here also I am explaining very slow. If you want to watch a speed mode, okay, your wish that is. Okay. So again I will redraw the diagram, otherwise confusion takes place. Very minute points. If you do little mistake, then the entire question will be gone. So I will take the diagram so that you can see the diagram carefully. This is spherical body, mass is m, here to here. This total distance given as 3L. Mass is small m. Another small m particle kept here, and this length is mentioned as L. Okay. Now we want F and F2. Which direction F is acting, that we need to focus. F is acting. F is the force between capital M and near mass. Capital M and a near mass. I have written here. F is the force between capital M and a near mass. Okay. F2 we want. F2, where is F2 acting in this diagram? F2 is acting. F2 is the force between the capital M and the far particle mass. So this is the far particle and this is the direction of F2. Now write here what is F equation, what is F2 equation. F can be written as Newton's law of gravitation we need to apply. First we have applied Newton's laws. Now Newton's law of gravitation. F equals to G into capital M into small m divided by F is distance between these two particles is 3L. 3L whole square means this is 9L square. Similarly F2 value, here apply general equation. General equation you know, F equals to G m1 m2 divided by r square. This formula I have applied. Right. F2 value, F2 is again G into m into small m divided by total distance between this center to the last particle is how much? That is nothing but 3L plus L, 4L square, that is 16L square. Now substitute these two values in this equation. Let us take this is equation number 3. Substitute F value, F2 value in equation 3. So if we substitute, how much we will get? F value is G into M into small m divided by 9L square plus F2 value is G into capital M into small m divided by 16L square equals to 2 into M into E. Now again small m values we can cancel here. Wherever small m is there, take common and then cancel. So acceleration value we need to write now. So acceleration equals to, so A equals to G m divided by L square. I am taking G m divided by L square as common. 2A equals to G m by L square common if you take. So what left? 1 by 9 plus 1 by 16. Now cross multiply this equation. So G m divided by L square into cross multiply. So this is 144, this is 16 times and this is 9 times. So acceleration equals to 25 divided by this 2 I am writing in the denominator so that this becomes 144 into 2. So 288. 25 divided by 288 into G m divided by L square. This everything is acceleration of the particles. But in the question again they are not asking accelerations. right? Not acceleration of the particle. If they ask acceleration of each particle is how much, so that tension in this string becomes 0, means this should be the answer. Acceleration is this much. But they are asking about relation small m value with respect to capital M, how to relate. That means whatever the acceleration we got, substitute this acceleration in equation number 1. Very lengthy. Oh, next question also came here. Wait, I will shift this. थोड़ा सा नीचे शिफ्ट करेंगे हम, ठीक है. So acceleration we got, substitute acceleration A in equation number 1. We need to substitute this acceleration in equation number 1. So what is equation number 1? First of all, equation number 1 we have to see. Then we need to identify in equation number 1 what is the F value, what is the F1 value, what is the distance between the particles. बहुत टफ क्वेश्चन, बहुत लेंदी क्वेश्चन. क्या कोशिश करना पड़ेगा. नो नीड टू लीव द टफ क्वेश्चंस. वॉट एवर इट इज, यू जस्ट ट्राई. F minus F1 equals to MA, right? This is equation 1. F minus F1 equals to M into A. So what is F value, what is F1 value? We'll write here. What is F value, what is F1 value? Aside better we write in the diagram only. Each point please observe carefully. Don't go for give up mode. Always fighting attitude required towards the tough questions. ठीक है. Here equation 1 states that F minus F1 equals to MA. So we want F value, we want F1 value. From this diagram, F value how to write? Again identify what is F. F is the force between small m near particle and center particle. So F equals to G into capital M into small m divided by distance is 3L. 3L whole square is 9L square. And F1 we want. What is F1? F1 is the force acting between small particles, right? So F1 equals to G into small m, that is small m square, divided by distance between small particles is L, so this is L square. So whatever F value, F1 value we got, will substitute. F means G m into capital M. We will shift this one only downward directly so that we can relate easily. Come on, everything. Come down. Yes, keep it here. Now see, F value means how much is the F value? That is G capital M into small m divided by 9L square minus F1 means G m square divided by L square equals to m into. Now acceleration means this entire value, whatever the value we got acceleration, substitute here. So this is 25 divided by 288 into G m divided by L square. Now here if you observe anything we can take common. Now L square values we can cancel first of all. This L square, L square, L square cancel. And here anything left? Small m. Yes, small m here, small m here. Here also m square is there, one small m gets cancelled. G value, G value, G gets cancelled. So what left? Just we write those terms only. Let us take here, this is capital M divided by 9 minus small m equals to 25 capital M divided by 288. Now simplify this whole equation. We want a small m value, right? Because in the question they asked about small m. So small m can be written as m by 9 minus 25 m divided by 288. So small m equals to, take capital M as common. If I take capital M common, this becomes 1 by 9 minus 25 divided by 288. Right. So we need to simplify this everything to get the value. So m equals to capital M into, what we can take common here, this is 9 into 288. Just cross multiply the values. So this becomes 288 minus 25 into 9. Let me calculate. A very lengthy question here. This is 25 into 9, 225. So that capital M, 288, 225 minus 288, so 63. So 63 divided by 9 into 288. Right. So here 9 one time, 9 7 times. So finally we got m value equals to, that is m equals to, small m equals to capital M into 7 divided by 288. Here in the question what they are asking, what is this numerator? Numerator value not given, so numerator value we got 7. So answer for this question should be 7. Here answer is 7 for this. Here this k value should be equals to 7. So this is 2015 advanced question. Little lengthy question, very carefully how to analyze what are the forces acting on the particle, how much is the distance between the particles, so how to apply Newton's laws of equation, then how to connect with the gravitation, and then simplification also they verify. Okay, very good question only, quality is there in the question, so just practice this question once again. Okay. Now next one, 2016 advanced, this is, we'll shift this question downward. आजाओ नीचे आ जाओ और नीचे. This is 2016. Next question will shift this even more down because we want space. Yeah, occupy a lot of space. ठीक है. This is 2016 question. Let us just read this question once. A straight rod of length L extends from x equals to a to x equals to L plus a. This is not a point size body. Very informative question it is. Whatever the question you have solved in the class in gravitation, every question, F equals to G m1 m2 divided by r square. This formula you have applied. That formula is valid only for point size particles. If the given object is extended body, if you see this question, this is a rod, metallic rod, means example is your pen only. Pen mass is not concentrated at one point. Some mass is distributed initially, then midpoint, then final point, like this. Mass is distributed along the length. So it is extended body. For extended bodies, gravitational law equation we cannot apply directly. So only one method is there, integration method we need to apply. Why we have to apply integration method, and how would we know that we need to apply integration method? That we will discuss in this question. Just see this question once. A straight rod of length L extends from x equals to a to x equals to L plus a. The gravitational force it exerts on point mass m at x equals to 0 if the mass per unit length of the rod is a plus bx square is given by. Means here linear mass density, you can see that the variety of this question is mass is also not constant. The question is even more tough. Basically they will give that a rod they will give, and the rod is extended case, so that integration method we will apply. Mass may be constant they give, but here mass is also changing. Sir, how can you say mass is changing? By look at the question here. Mass per unit length. Mass per unit length is changing this much. If mass per unit length is changing, means entire rod mass per unit length changing mass is a variable mass. So we need to apply here integration. So how to proceed this question, let us see. Take a metallic rod. So we have taken here, there is a metallic rod given, and this metallic rod has a length L. As per the question, its length is given as L. Rod length is L. Okay. Now there is a point mass. This rod is applying some gravitational force. It exerts on a point mass, right? Given mass, another mass is a point mass. And the distance between these two we can take. This rod starts from, initial end starts from what distance as per the question? It starts at a distance A. And what is the final distance of the rod from point? Final end is at a distance of L plus A, right? So see this diagram, point mass is there, a metallic rod is given. Metallic rod length is L. Point mass is small m. Now this rod is applying gravitational force on the point mass. Can we apply F equals to G into m1 m2 divided by r square formula directly in this question? We cannot apply. What is the reason for that? Because here rod is extended body. Extended body means different particles or different elemental mass apply different forces. So we cannot apply gravitational force directly. So what is the meaning of different particles, different masses? Let us see. First particle is given elemental mass. What is the distance between this particle and the elemental mass? Maybe x1. Here distance is different. So if you apply directly formula, you will get F equals to G m1 small dm divided by x1 square you will get. If I take this end particle, if I take this mass, then this is also having elemental mass dm. But what is the distance between the particle and this last mass? It may be x2. Let us take x2. Then what happens to the gravitational force between last elemental mass and the point mass? G into m1 into dm divided by x2 square. Now you just observe. Here x1 is different, here x2 is different. If x1, x2 are different, then f1, f2 also different. So we cannot say which is the force acting on the particle. So individual elemental masses are applying different forces on the given point mass. So direct formula is not applicable. Then what is the process? Only process is integration. We need to do here integration. Here I will remove this one. Right. This everything also will remove. Need diagram again will draw. Sure. Okay, so let us take there is a metallic rod and a particle is given, small particle having mass m. Initially the rod is at a distance A, initial element is at a distance A, and the final element of the rod is at a distance L plus A from the given point mass. Rod length is L. Now what I will do is, for integration purpose, it is a linear object, so I will take small element here. This small element mass is dm. I am taking dm. So distance between the point size particle and the elemental mass is x. I am taking. Now you just find out the small force. What is the small force acting between the given point size particle and small m? So here's df can be written as g into dm into point particle mass m divided by distance between these two I have taken as x. So I am writing this one as x square here. Now to get the total force, this is the small force applied by the elemental mass. dm stands for elemental mass here. So if this is the force applied by elemental mass, then how to get the total force by the entire rod? So apply integration. So F equals to integration of g into m into dm divided by x square. So g is a constant, write it outside. Small m is a constant, write it outside. What are the variables? That is dm divided by x square. So this is g into small m into dm can be written as, how to write dm in terms of linear mass density. Why we have to write dm into linear mass density? Because in the given question they mentioned mass per unit length, that is a linear mass density. So dm equation is, right here dm can be written as lambda into dx. Very important relation. If area distributed mass mentioned, that means dm equals to sigma into dA we have to take. If mass is distributed along volume, then dm equals to rho into dV we have to write. Clear? So like this we need to take, this is the required relation, dm equals to lambda into dx. So instead of dm I will substitute this value. So lambda into dx divided by x square. Lambda means linear mass density, value given in the question itself, it is a plus bx square. So substitute that value. So this is gm integration of a plus bx into dx. A plus bx they have given, right? So a plus bx square they have given. Okay, a plus bx square dx divided by x square. Now separately integrate, separately, so that this is gm as it is, integration of a dx divided by x square plus integration of b dx. X square gets cancelled if I write separately for b. So directly I have written b dx. Now limits, from where to where limits we need to take. Limits also plays very important role. If you take wrong limits, answer is also wrong. Okay. How to choose the limits? First to see where is the initially rod starts from which distance from the given point size particle. This is the point size particle. A rod starts from here. So what is the initial distance? A. So lower limit is A. Where is the final rod distance from the point size particle? Final distance is at L plus A. So upper limit should be L plus A. Here. So here also limits from A to L plus A. I hope you can do this integration. I want to give this as a work only. Whatever the concept is there, why to apply integration, I told integration we have to apply because the force is changing continuously with respect to distance. If a force is changing continuously with respect to distance, directly we cannot apply the formula. For that purpose, what we need to do, choose the small elemental mass and then apply integration method by taking proper limits. So everything we have done, we need to do integration only. I think you can do it, right? So, okay, I just solve this one till the end. Integration I will also do. So gm, keep it as it is, gm, and here a is a constant. We can write a value outside also, so that x square I am writing in the numerator. Step by step I am writing. Okay, if any student has a trouble in integration, they will learn. X power minus 2 dx plus b is a constant, integration of dx. Limits will substitute here. So limits from a to a plus l. Here also a to a plus l. Okay. Next step is, this is gm, a is a constant, x power minus 2. What is the integration of x power n? X power n plus 1 divided by n plus 1, you can know. So that directly I will write here x power minus 2 plus 1 divided by minus 2 plus 1 plus b is a constant, integration of dx is nothing but x. So limits are same. Limits we need to apply now. A to a plus l is also a to a plus l. Next equation is, so gm a, this everything I write like 1 by x, negative is there, so that minus we need to write, so minus of this minus I'll write here outside, okay, plus b into this is x. Limits we will substitute common limits, so a to a plus m. So this is minus g m into, first of all, upper limit. What is the upper limit here? A plus l. Upper limit minus lower limit is how much? Lower limit is a plus, this is b into, upper limit is a plus l, lower limit is a. So that final equation is minus g into m, so 1 by a plus l minus 1 by a plus b into minus a plus a gets cancelled l. So this should be the final answer. This much is the force acting here. The final answer is this. So apply the integration, take the limits, and then do the integration method. Very standard question. Speciality of this question is whatever they have given in 2026, I think same model they have asked in 2021 mains, not in advance. Whatever the question they have given in 2016 advance, same question in mains also 2021 they have asked. Standard model, don't remember anything, any formula, no need to by heart, just depend on the process. Maybe by hearting the formulas, all those valid for JEE mains, not for advanced questions. Very deep also, some question they will test your knowledge. Next one. Next is 2017 question. It is, this also will shift a little bit down. Right, so 2017 it is. First read the question, pause the video, okay, try yourself, understand the question. Questions are little lengthy only, we need to understand the question properly, then we have to apply it. If calculations are there, more lengthy calculations, all the methods I will explain. Just at the end, calculation purpose I will give to you as a work. Okay. Now, a rocket is launched normal to the surface of the earth away from the sun along the line joining the sun and the earth. The sun is 3 into 10 to the power of 5 times heavier than the earth and is at a distance 2.5 into 10 power 4 times larger than the radius of the earth. The escape velocity from the earth's gravitational field is 11.2 km per second. This is given, and sun is at 3 into 10 power 5 times heavier than the earth. Okay, mass means the distance is this much than the radius of the earth. Okay, required data is given. The minimum initial velocity required for the rocket to be able to leave the sun earth system is closest to 2. Ignore the rotation and the revolution of the earth and the presence of any other planet. If any other planet is present, means what happens? We need to give such a velocity so that it has to escape from the earth, from the sun, from the other planet field also. That's why we need to ignore there is no other planet present nearby, only sun and earth are present. Okay. Single equation, equation is single equation, but calculation is there, that's why they have given in advance. Okay. Equation I will write, calculation whatever is there, you just take it as a work. I will give the idea with help of a diagram. Let us take, there is sun here, the sun given, okay. Next earth, so this is earth, of course small compared to the sun. Okay, this is the position. This is center of the sun and this is center of the earth. A rocket has launched from a perpendicular to the surface of the earth away from the sun. As per the question, it has launched away from the sun along the line joining the earth and sun they have given. Okay. Escape velocity on earth's surface, we know it is 11.2 kilometer per second. What is the meaning of this? Per second, for 1 second the rocket has to cover 11.2 kilometers, then only it can cross the gravitational field. Means whatever the rocket we are launching into space, every object has a minimum this velocity 11.2 kilometer per second we have to impart. Otherwise what happens, whatever the rocket is there, it just comes back and falls on the surface of the earth only. It cannot enter into the space. So this much is the minimum velocity required to escape the gravitational field. Taken. And here mass of the earth I am taking as m suffix e, mass of the earth. Radius of the earth is r suffix e I have taken. Mass of the sun ms, and here distance between these two means here distance between the sun and the planet, whatever the planet we are launching. This distance they have given already. How many times they have given, everything we will write. So mass of the sun is given as, in the data they mentioned that 3 into 10 to the power of 5 times heavier than the earth, means 3 into 10 to the power of 5 times mass of the earth. So here mass of the earth I have taken me, and here this is 3 into 10 to the power of 5 times of me. Radius of the earth is re I have taken, and here distance they mentioned that distance is how many times than the radius of the earth. Distance is 2.5 into 10 power 5 times larger than radius of the earth. So 2.5 into 10 to the power of 4 times larger than radius of the earth. Now which equation we have to apply? Same, I think you have learned escape velocity. Same, how to write escape velocity plus potential energy equals to, if any particle is about to leave the gravitational field, then final energy becomes 0. Same equation, conservation of energy we have to apply. So initial energy of the system should be equals to final energy of the system. What is the initial energy of the system here? That is, we are giving this rocket to certain velocity. Let us take, we have given v velocity, and mass of this rocket is small m I am taking. Small m is mass of the rocket. Now apply, what is the potential energy of this system initially? So potential energy between the sun and the planet, that is minus g into mass of the sun into mass of the rocket divided by distance between the satellite and the sun, minus what is the potential energy between the earth and the planet, means earth and the rocket, that is minus g mass of the earth into mass of the rocket divided by radius is r, radius of the earth is r, plus we need to give certain velocity. Initially we have to give some velocity, otherwise planet cannot escape, right? Whatever the rocket is there, we have to give some initial velocity, then only it can escape. So we are giving velocity, means the rocket has kinetic energy, that is half mv square equals to, if it is about to leave the gravitational field, let us suppose due to these two gravitational field, maybe here this is the limit of gravitational field. So finally the rocket has reached here. If the rocket reached to the end of the gravitation field of the system, what happens to final energy? So at the highest point velocity becomes 0. If velocity is 0 means kinetic energy is 0, and once it crosses the gravitational field, there is no interaction between the system and the satellite. If there is no interaction means potential energy becomes 0, because potential energy is nothing but interaction energy. If there is no interaction means there is no potential energy. So kinetic energy is 0, potential energy is 0, so final energy also becomes 0. Okay. Now we want this v value. So how to write that? So half mv square equals to, write this all negative terms towards right side. So this becomes g mass of sun into mass of the planet divided by d plus g into mass of the earth into mass of the rocket divided by re. Now here we can cancel small m. If you observe left side and right side, we can cancel small m. Mass of the rocket we can cancel. That means if you are cancelling mass of the rocket, means what we can conclude, very important point here, escape velocity does not depend on mass of the rocket. Clear? Escape velocity does not depend on mass of the rocket. Whether you are launching a heavy rocket or a less massive rocket does not matter. We have to give escape velocity 11.2 km per second for the earth planet. Okay. Mass of the rocket gets cancelled here. What left here? So v square by 2 equals to g into, now apply the conditions. Mass of the sun is how many times mass of the earth they have given? See the data. Mass of the sun equals to 3 into 10 to the power of 5 times. Mass of sun is 3 into 10 to the power of 5 times mass of the earth divided by distance. Distance of the sun to the planet initial how much? 2.5 into 10 power 4. 2.5 into 10 to the power of 4 times of radius of the earth. This is the distance given in the question itself, plus g into me divided by re. Now v square value we want, so v square equals to, cross multiply with this 2, so this becomes 2g me divided by re into, if I take root, sorry, 2 can multiply, 2 into gmu you can take common also, so that 3 into 10 to the power of 5 divided by 2.5 into 10 to the power of 4. You understand? Here I have taken common g me re. Here also g me re. I have taken common, and whatever the 2 is there, I have multiplied the whole term. Clear? So 2 is g me divided by r we got, and we left with this, and the plus 1 also comes here. This plus 1. Now if you simplify this everything, you will get v value. Here I hope you can do this one. V you will get how many kilometer per second, like that you will get the answer. Clear? This is the entire process. I hope you understand this one. Calculations you do it, don't neglect the calculations. You just listen this question once and then solve by yourself. Calculation also you do at that, you will get the answer. This is the entire process for the given question. Okay. Next question is 2018 advance. Okay. Previous question is 2017 advance, right? This is 2018 advance. MCQ type given. Basically they give MCQ types. Most of the cases MCQs are from the units and measurements. So definitely they are asking one question. If you see last 4-5 papers from units and measurements, every year advanced question, paper 1, paper 2, both the papers we can expect one question from units and measurements. That too MCQ type they are asking. Mostly MCQ they will ask. If MCQ miss, then vernier calipers as screw gauge models they are asking mostly, right? Just to say this question here, a planet of mass m has 2 natural satellites with masses m1 and m2. Okay, 2 planets are there, masses m1 m2. The radii of their circular orbits are r1 and r2 respectively. Okay, ignore the gravitational force between the satellites, right? Define v1, l1, k1 and t1 to be respectively the orbital speed. Very important is v1, l1, k1, t1. What are these v1, l1, k1, t1? Orbital speed, angular momentum, kinetic energy and time period of revolutions. Okay. Similarly, V2, K2, L2 and T2 be the corresponding quantities of satellite 2. Given M1 by M2 relation this much, means M1 by M2 is how much? R1 by R2 is how much? This much. The relation is given. We need to match. Okay, V1 by V2 how much? L1 by... Here after seeing this question, you can write V1, V represents orbital velocity. As per the given question, this is the relation. V stands for orbital velocity and L means angular momentum and K1 or K generalized I am writing, K stands for kinetic energy and then T stands for time period, right? So this is time period. So these are the given quantities V, L, K, T, and we need to find out here relation also given. M1 by M2 value how much is given? M1 by M2 equals to 2. So which gives the information of M1 equals to 2 times of M2. Okay, M1 equals to 2 times of M2. R1 by R2 equals to, here R1 by R2 value mentioned as 1 by 4. That means R2 equals to 4 times of R1. Okay, this is entire given relation. First of all, orbital velocity means we know what is the formula for orbital velocity. SK velocity formulas, orbital velocity formulas, I think you remember. Otherwise we can derive also in a minute, it does not matter. So orbital velocity, I hope everyone remembers, so directly I will write here. Orbital velocity formula is root over gm divided by r. This is orbital velocity formula. So orbital velocity v1, first planet orbital velocity is v1, second planet orbital velocity is v2. So v1 by v2 equals to root over gm divided by r1 whole divided by root over gm by r2. Because here g is a constant, capital M is a constant, capital M is mass of planet. Students will do mistakes here also. Capital M is not mass of the satellite. Whatever the satellite revolving, orbital velocity does not depend on mass of the satellite. It depends on mass of the planet. So capital M stands for mass of planet. So gm is a constant, gm is constant, both are same, we can cancel. So v1 divided by v2. How to write v1 divided by v2? Then reciprocal of the radiuses. v1 by v2 equals to square root of r2 by r1. R2 and R1 relation is given. What is R2 value here? Let's see, R2 value is 4 times R1. So substitute. Instead of R2 you can write 4 times of R1 divided by, this is R1. R1 value gets cancelled. So V1 by V2 equals to root 4. Root 4 means 2. So this should be the answer here. V1 by V2 ratio should be equals to 2. Here. So just to see this question here, V1 by V2 ratio is 2. That means for P, answer should be, answer we got 2. That means option should be 3 here. So for P, 3 is there. For which one? For A, no. For P, yes. For P, option should be 3. Any other? P, 2 is given, no. P. If this question comes in advance, then directly, of course this question came, and here directly we can mark option as B, because only one option we need to verify, and if our calculation everything is correct, no doubt damn sure the answer should be B only. Then we no need to verify other options, no need to waste our time. Instead of solving other option, you can go for the next question also in the exam. Okay. But here it is a process of learning. Just now you are learning all these, how to analyze all those tough questions, how to solve, right? So that's the purpose. I will explain remaining options also, how to match. But in the exam, if you see these type of questions, there is no other option correct which has verified clearly. So option is B. Directly you mark option B and go for the next question. Don't spend time on this. Okay, first one we have verified. Next, angular momentum ratios. First one verified is over. First option verified. Second option, that is angular momentum. So again, formula for angular momentum, I think everyone knows. We have discussed in terms of inertia also. I have given L equals rotational mechanics. Try to remember L equals to I omega, L equals to mvr. Right, two formulas are there for angular momentum. So general formula for angular momentum, L equals to m into v into r. Right, L equals to mvr. Now L1 by L2, that means L1 by L2, ratio of angular momentum equals to m1 v1 r1 divided by angular momentum of second particle is m2 v2 r2. So m1 value is how much? Now see the data again. As per the data, m1 value is 2m2. Substitute here. m1 value is 2m2 and this is v1, and r1 value write r1 only divided by m2. Second particle mass is m2 only, velocity is v2, but r2 value how many times? 4 r1. So r2 value is 4 times, so 4 r1. Now cancel the terms, whatever the terms gets cancelled here, cancel them. So m2 value gets cancelled, r1 value gets cancelled. So remaining is, here in the numerator 2 is there, but v1 by v2, this ratio already we have calculated. What is v1 by v2? We got 2. So this v1 by v2 value is 2. Substitute is 2, and anything left here? This is 2, this r1 gets cancelled, here 4 is there, this is 4. So 4 gets cancelled, it should be 1. That means for Q, what should be the option here? 2. Option is 2, answer is 1. Don't get confused. 1 is there for 2, so for Q, answer should be 2. Next, third one, case 3. What is the relation given for the third? Which physical quantity? K1 by K2, kinetic energy ratios. Kinetic energy, general equation everyone knows that, half into m into v square. Now ratio they are asking, so K1 by K2 equals to half into m1 v1 square divided by half into m2 v2 square. I think I am explaining slow only because maybe a slow learners also maybe trying for tough questions. That is the purpose. If you want to watch fast, I think you can adjust, right? If not possible for fast watch, you just click here, the video goes a bit fast. Okay. Here substitute again, whatever the cancel the things, half and half gets cancelled. M1 value, what is the M1 M2 here? M1 value is how many times? 2m2 times. So this is 2m2 into v1 square divided by m2 into v2 square. So m2 value gets cancelled. This is 2. v1 by v2 ratio how much? v1 by v2 ratio is 2. v1 by v2 whole square is 2 square, that is 4, which is 8. So kinetic energy ratio, K1 by K2 ratio should be 8. That means for option R, it should be 8. That means 4. Here. Next, last one, time period, T1 by T2, fourth one, time period. I think you can do this one. So T1 by T2 equals to, I just write the equation, you just simplify, 2 pi R1 divided by V1 whole divided by 2 pi R2 whole divided by V2. Here anything gets cancelled, 2 pi value gets cancelled, so we can write this equation as R1 V2 divided by R2V1. So here everything you know, if you simplify with help of known values, so that you will get the option as 1 divided by 8. For S, answer should be 1. Here 1 divided by 8 you will get. So this is the question we asked in 2018 advance. Next question is 2029. Whatever are there, I have given. 2019, I think question is not there, so I have not given here. So I have taken almost all the PYQs, recent 10 to 15 years PYQs I am selecting. If I feel that very old PYQs also, if I think that very good quality, then I will explain those also from the next chapter. Right, this is the question from 2021. Right, see this question here. The distance between two stars of masses 3 ms and 6 ms is 9 r. Here r is the mean distance between the center of the earth and the sun, and ms is the mass of the sun. Okay. The two stars orbit around their common center of mass in circular orbits with a period nt, where t is the time period of the earth revolution around the sun. The value of n is. Okay, so how to analyze this question? It is a two planet systems. This question relates with center of mass concept, because here two planets are given and both the planets are rotating, revolving around their center of mass, they said. That means question is based on center of mass and application of gravitation force formula. Means Kepler's law equation we need to apply here. Means not Kepler's law equation, square of mv square by r equals to g m1 m2 by r square. Centripetal force means horizontal circular motion application is there, gravitation force application is there, and center of mass concept. So total 3 concepts we have to apply to analyze this question. Okay, not a big issue, we can solve this question. Let us take, there are two particles separated by certain distance. So we'll take here 2 methods are there for finding center of mass. Both the methods I will give you, but I prefer the first method. I will tell what is the first method. So that basically I use. 2 particles, both are separated by distance. Let us take distance between the particles given 9r. Okay. So this is one particle. This is another one. This is heavy mass. Because masses are different. You see the question carefully. One is having how much is the mass? 3 ms. Mass of other one is 6 ms. And 9r is the total distance between them. Okay. So total distance between the particles is given as 9r. Okay. This is 9r. Now this is having mass 3 ms. 3 ms. And it is having mass 6 ms. Here. Next. Here method 1. I will proceed basically by taking method 1 only for solving center of mass concept questions. What is the method 1? Method 1 is, if you observe this diagram, 2 particles are there. This object you can consider. One particle is arranged at one end, other particle is arranged at another end. Both are having masses. What is the nature of center of mass? In the beginning I told, center of mass chapter beginning also. Center of mass always lies closer to the heavy mass side. I repeat, center of mass is always close to heavier mass side. That means center of mass is away from the lighter mass. Okay. In this also, where is the heavier mass? Heavier mass is 6 ms. Lighter mass is 3 ms. Means center of mass is close to 6 ms only. Right? This is position of center of mass. Now about this center of mass, both are rotating. Both the particles are rotating, means revolving. Revolving around what? They are revolving around center of mass, their own center of mass. Okay. So what is the distance here? Center of mass distance is how much? From here to here, what is the distance? We don't know. Similarly, what is the distance from 6r to this distance, how much? We don't know. So we need to find out the position of center of mass. First of all, position of center of mass we need to get. So position of COM, position of center of mass. How to get the position of center of mass here? So I'll use the equation. Let us take this distance I am taking as R1. This distance is R2. To get R1 distance, we can write R1 equals to, what is the other particle mass? R1 is the distance from 3 ms. So take the other mass is 6 ms. This is the finding center of mass position. Shortcut, directly you can write in one. Basically I don't give any shortcuts. I don't believe in shortcuts, because shortcut has certain conditions. If this happens, this we can apply. If this is given, this formula we have to apply. This is shortcut. It has a limitation. Purely depend on the original methods. Along with that, if you want to learn shortcuts, it is fine, but never forget the actual methods. Okay? In advance, you cannot solve by taking shortcut methods. Most of the cases, shortcuts will not be applicable also. Such type of question they test the knowledge of the candidate from the deep ground level knowledge you have or not. Very basics are strong or not, they will verify that, not your shortcuts. So R1 equals to, other mass is 6 ms. What is the total distance between the particles? 9r divided by total mass is 9 ms. So 9 gets cancelled, ms and ms gets cancelled. So R1 value is how much? 6. R1 value is 6r. So directly you can write this value is 6r. Total distance is 9r. 3 ms is at a distance 6r. That means 6 ms should be at 3r distance. It is very simple thing. Finding center of mass. This is method 1. What is method 2? Method 2 here. Finding position of center of mass. Take XEM. XEM equals to, for two particle system, what is the equation I have given? M1 x1 plus M2 x2 divided by M1 plus M2. So by using this formula also will get, you can take here x1 is 0, x2 value is a 9r, and then simplify the equation. You will get the same answer. Answer will not be changed. Same answer you will get. Clear? If you want to verify, you can see XEM equals to, M1 value is 3 ms I am taking, and I am considering 3 ms is at origin, so that x1 becomes 0, plus M2 means 6 ms, and what is the x2 value? From the origin, 6 ms is at a distance 9r. So this is 9r divided by total mass is how much? 6 ms plus 3 ms, 9 ms. So XCM equals to, in the numerator, 6 ms into 9r whole divided by 9 ms. So ms value gets cancelled. 9 and 9 gets cancelled, so we left with 6r. So same answer we got. Any method you can use. Okay, this is not shortcut method. There is no shortcut method here I am using. Actual method only, with that two processes are there. Methods are different. That's it. One is direct to formula derived method. One is by taking the approximations method, R1 R2 methods. Both will give the same result. Now we got center of mass position, that is fine, but they are not asking again center of mass. If they ask center of mass, answer is over. What they are asking, time period we need to relate. For that, this 3 ms is revolving, right? 3 ms is revolving around center of mass. I just redraw this diagram, same diagram, I just copy it. We'll take the required part only. This Okay, this entire part I will copy and I will paste here. Okay, now I'll do one thing. This also not required. Remove this. Okay. This 3ms is revolving around center of mass. Now use gravitational force formula and centripetal force formula. 3ms is revolving around center of mass. That means any particle which is revolving in this center of mass means what happens? What is the force acts towards the center? We can write the force acts towards the center. Basically it is revolving like this. This 3ms revolves around the center of mass. Center of mass should be at the center of the circle here, right? It is revolving around center of mass. So I will write here Fc, centripetal force, should be equals to gravitational force here. Any particle which is rotating in the circular motion, revolving in the circular motion means centripetal force is there. Centripetal force is not a new kind of force. It is any force which is acting towards the center. If gravitation force acts towards the center, so gravitation force is centripetal force. If tension force acts towards the center, then tension is the centripetal force. So here two particles, massive particles are revolving. So obviously gravitation force is the centripetal force. So Fc equals to Fg. So centripetal force formula is, general formula I am writing first of all, mv square by r equals to g into m1 m2 divided by r square. This is general formula, right? Now we will apply this formula for solving this question also. This formula we will apply. Which particle I am analyzing first? 3ms. Let us take 3ms particle is revolving around center of mass. So equation becomes, which particle revolving? 3m. So 3ms into, it is revolving with velocity, we don't know the velocity, let us take v square divided by, what is the radius value? Radius is nothing but distance from center of mass to the 3ms. How much is the distance? 6r. So here you can write 6r, which equals to gravitation force between the particles is how much? G into one particle mass is 3ms, other particle mass is 6ms, divided by total distance between these two particles. What is the total distance between these two? 9r. So that r square is there, that means 9r square. So it becomes 81r square. I hope total distance between these two particles is 9r. In the formula square is there, so 9r whole square, it becomes 81r square. Whatever the things gets cancelled, you can make them cancel here. R square, 1 square gets cancelled, 1r gets cancelled. Here ms value gets cancelled, here ms 3. Okay, now we left with v square divided by 6 equals to g into 6ms by 81r. Right. So v square can be written as 36 gms by 81r. V value, time period we want. So time period I will relate like by taking time period value, you can relate to v equals to r omega also we can write here, but I will write individually. T equals to 2 pi r divided by v formula I will take. Okay. So v equals to square root of 36 gm divided by 81r. This is velocity we want, right? Velocity equation I got. Now I know velocity, I know what is the radius also, so that we can find out the time period. Time period they are asking, so formula for time period is what? So time period equals to T equals to 2 pi r by, this question will shift again. shift down. Okay. Now time period. So time period can be written as t equals to 2 pi r divided by v. So this is 2 pi into r value. How to write r value here? R is nothing but radius of the planet. So radius is how much time taken to complete one rotation around the circle. Here this is 6r, right? Radius is 6r. 6r divided by velocity value. Velocity I will write root 36 is there. This can be written as 6 upon 9 root over g m divided by r, right? Root over gm divided by r we can write. Now anything gets cancelled, we can make them cancel also. Let's keep it like this. So t equals to 1 minute. Okay. So t equals to 6 and 6 gets cancelled here. Make them cancel, so that we left with 2 pi r divided by square root of g m divided by r. 1 by 9 is there, so that 9 goes to the numerator. Now we need to compare with the time period of this earth, I think. So this is 9 times of 2 pi r divided by root over gm by r. Keep root over gm divided by r, right? So any options given, let me check. Circular orbits with period nt. T is the time period of earth revolution of the around the sun. The value of n is, here they are rotating the two orbits. Okay. Right. Here this becomes, if you observe this everything, this is what? Nothing but orbital velocity. Orbital velocity is root over g m divided by r only we will write. So that this entire equation becomes, this is t dash. Better you take other time also. This becomes a t dash also we can write. Time taken by the planets to revolve. So this is 9 times of time taken by the earth to rotate and the sun we can write. So 9 should be the answer here. 9 times. I hope you understand this. Everything just to go through here. First of all, center of mass concept we have to apply. Identify the center of mass, then find the position of center of masses. Now take any one particle which is rotating here around the center of mass position. So that here two methods again you can solve from here also. Instead of taking v value can take as r omega square also you can write. Omega can be written as 2 pi by t whole square. That method also fine, right? So if you simplify everything here, you will get the answer as 9. Clear? How it got a time period of the earth here I have taken, because 2 pi r by root over gm by r. What is root over gm by r? Nothing but the orbital velocity. So 2 pi r by v, which rotates, time taken to complete the rotation motion around the sun. It is 9 times we got here. Next question is this question. This is 2021. Okay, next one 2023. See the complete question. Two satellites P and Q are moving in different circular orbits around the earth. The heights of P and Q from the earth's surface are HP and HQ respectively. Okay, where HP equals to R by 3. The acceleration of P and Q due to Earth's gravity are GP and GQ respectively. if the ratio of GP by GQ equals to 36 by 25, what is the value of HQ? They're asking. Okay. Just pause the video and try it by yourself. Just try to connect with the formulas. Right. Two satellites P and Q are moving in different circular orbits around the Earth. The height of P and Q from the Earth's surface are HP and HQ, where HP value is R by 3. Okay, acceleration due to gravity ratio is also given. What is the height of HQ? They are asking. Okay, let us see. They are revolving in around Earth. Okay. Let us take our planet Earth. Okay, this is our planet having radius from here to here. Its radius is R, mass is capital M. This is our Earth. Now a planet is revolving in circular orbit. So this is the first planet I have taken, which is revolving in the circular orbit. And let us take, this is another planet which revolves again in the circular orbit only. Let us take, it maybe seems to be elliptical or whatever may be the path. Okay, so assume perfectly they are rotating in the circular orbit. First particle is this one. This is the first particle and this is the another particle. Two particles are there, right? Both the particle means here satellite. What I mean, both the satellites are revolving around the Earth at different heights. What are the heights also we don't know. Here they have given heights. Height of P is given as R by 3 they mentioned, and the height of the Q we need to calculate. The ratio of gravities they mentioned. Okay. So here what I will do is, I take as per the given data that for planet P, acceleration due to some voltage dim is there here. Just a minute. Wire connection. Okay. Let me give a minute. I had some wire problem. Alright. Okay. So gravity. So G at certain height. What is the formula for gravity at certain height formula? G at certain height equals to G divided by 1 plus H by R whole square. Right? I think, can you see if I write here? I am writing, I think maybe my videos you cannot see if I write here. Let me adjust this. I erase this. Okay, start writing from here. Gravity at certain height H equals to G divided by 1 plus H by R whole square. This is the gravity formed at certain heights from the surface of any planet. Okay, so this is a height formula. Now I apply this formula to the given conditions. Gravity of planet gravity at certain height for planet P, for planet Q they have given. Let us take gravity for planet P equals to G divided by 1 plus, what is the height of the planet they mention here? Height of the planet given as R by 3. For P planet they have given H value R by 3 into R whole square. Instead of H, how much we need to substitute here? Because height of the planet given as R by 3. Just to substitute this in the formula, that's it. Next, simplify this. So gravity of planet equals to G by 1 plus, here r value gets cancelled, this is 1 by 3 whole square, so that G by 3 plus 1, this is 4 by 9, so 9 by 16 it becomes total value, gravity of planet P. Here take LCM, 3 plus 1 4 by 3 whole square, so that 16 by 9 come, 9 goes to the numerator, so 9G by 16, this is gravity of planet P. Next, gravity of planet Q, how much? Not given. Gravity of planet is G divided by 1 plus height of planet Q divided by R whole square. They are asking what is the height of the planet Q from the given planet, what is the height of the given satellite. They are asking HQ, we need to find. So let us take, this is equation number 1, this is equation number 2. But as per the given question, the data is GP by GQ is 36 by 25, right? So GP divided by GQ equals to 36 divided by 25 they have given, right? GP by GQ is 36 by 25, correct. Now substitute here. So GP value is how much? 9G by 16 divided by GQ value is G by 1 plus HQ by R whole square equals to 36 by 25. Any terms gets cancelled, make them cancel here. G value gets cancelled. Any other terms? No. So that rewrite the equation step by step. I'll write 9 by 16 whole divided by 1 by h plus, so that you can reciprocally it becomes 1 plus HQ by R whole square equals to 36 by 25. So 36 divided by 25, cancel the terms here, 9 one time, 9 4 times, so 1 plus HQ by R whole square equals to 64 by 25, so 1 plus HQ by R value is 64 by 25 whole square, I have removed, so that this becomes 8 upon 5, which is HQ by R equals to 8 by 5 minus 1, that means 3 by 5, right? So that HQ is 3R by 5. This should be the final answer for the question. 3R by 5. Option is there here, right? 3R by 5. This is the option. Clear? We'll just see here step by step, nothing is there. This question is easy. I felt that this is not actually an advanced level question. Whatever the questions we have discussed, this is the question which is a less level, I think. Question number, this is 2023 question they asked. Next question is advanced 2024. Again, just a minute to look at the complete question here. A particle of mass m is under the influence of the gravitational field of a body of mass capital N. Capital M is very greater than the small m. The particle is moving in circular orbit of radius r0 with a time period t0 around the mass m. Then the particle is subjected to an additional central force corresponding to the potential energy is given this much, where alpha is a positive constant of suitable dimensions and r is the distance from the center of the orbit. If the particle moves in the same circular orbit of radius r0 in the combined gravitational potential due to m and vr, but with a new period t1, okay, then t1 square minus t0 square whole divided by t1 square is given by. Question is very easy, but lot of calculations are there. So many steps are there. This question, I felt, of course, very good quality question it is. I will solve step by step. Maybe if calculation is there, lot of calculation. At the end, I will give as a small work to you. Everything I will explain detailed. Just say this one. Let us consider a particle is revolving in the circular orbit. First of all, planet, a body mass m, particle mass is m, and radius is r naught, time period is t naught. Okay. Let us take the corresponding diagram for this. The shape required. Right. Its mass is m. There is a planet mass given as m, and a radius given as r. And a particle is revolving here. So a particle revolves. Take a simple diagram with that. This is capital M. A particle is revolving in the circular orbit. Orbit is circular orbit. It is revolving. Right. And radius is r. If any particle is revolving in the circular orbit, a force acts towards the center. This we know already. So any particle which is revolving in a circular orbit, a force acts towards its center. I delete everything because no neatness in the diagram. Okay, particle mass capital M, and it is revolving in the circular orbit. Okay, so particle revolving circular orbit of radius. If you take radius of this total, so radius is r, mass is m, and radius is r. So this is the given particle. Particle is revolving, mass of the particle is small m. Right. So any particle is revolving in the circular path means a force acts towards the center. So what type of force acts towards the center? The force acts towards the center is called as centripetal force. And here centripetal force is produced by what type of force? Nothing but a gravitational force. So particle revolving, so that a force is acting towards the particle, towards the capital M, and this is the direction of the force acting. So here gravitational force behaves as centripetal force. Both are same only. Centripetal force equals to gravitational force because gravitational force is providing centripetal force. So equation of centripetal force is mv square by r value. In the question, r value given as r naught. Here they mention this is r naught, time period t naught. Mass of the body is m, particle mass is small m. Okay, right. mv square by r naught equals to gravitational force between these two is, this is not capital R, then this should be small r naught as per the question. Okay, so gravitational force between capital M small m is g into capital M into small m divided by distance between these two is r naught. So this is r naught square because g m1 m2 by r square is the formula. So anything gets cancelled here, small m and small m gets cancelled, r naught and 1 r gets cancelled, so that v square equals to g into m divided by r naught. But here v can be written. How to write v value? V equals to r omega we can write, so that this becomes v equals to r omega. Since v equals to r omega, this equation we know. Substitute those values here. So v means r square omega square, which equals to g m divided by r naught. Here also r naught we will write. Everything is r naught, only radius they have given. So omega square equals to g m by r naught cube. Omega means what? 2 pi by t. Right? Omega can be written as 2 pi by t. Whole square is there. So this is 4 pi square by t square I am writing. I repeat, omega means 2 pi by t. Omega square is there. So 2 pi by t whole square, 4 pi square by t square equals to gm by r naught cube. So find out t square value. T square can be written as 4 pi square r naught cube divided by gm. Clear? Just cross multiplied. Now find out t value. T can be written as root over 4 pi square r naught cube by gm. Instead of taking here t, we will take t naught, because in the question they mentioned that as the planet is revolving around a given mass m, time period is t naught they have given. So better you take here t naught. So this is the time period we got. When this time period, whenever only a planet is revolving because of centripetal force, only centripetal force, that is gravitational force, is acting. Now see the question. What is the question? Very lengthy question. I'm telling, question is very tough and high quality question only. Calculations also matters a lot. So particle mass m is under the influence of only gravitational force influence is there. This is the time period we have calculated. But they are not asking that. Then the particle is subjected. Actual question starts here. Then the particle is subjected to an additional central force corresponding to the potential energy this much. Potential energy given. Corresponding to the given potential energy, if additional force acts, then what should be the time period? What should be the new time period they are asking? I repeat the question. Understanding question is important here, moreover solving. Initially particle revolving around a mass m, a small particle is revolving. What is the radius here? Radius value is r naught. What is the mass of the particle? Small m. As this particle is revolving around the m, only due to gravitational field we got time period value calculated just now. But what they are asking, including this gravitational field, there is another force also acting. Why another force is acting? Other force is acting due to the gravitational energy, gravitational potential energy. Due to this, another force also acting. Because of these two forces acting on the particle, there is a new time period generated. So what is the relation between the new time period and the time period of the first case? They are asking with respect to the given equation here. Now potential, if a gravitational potential energy is given, then how to find out the force? There is a relation here, right? Relation we need to identify. What is the relation between force and the energy? So first of all, I will write the given equation here. V given as m alpha divided by r cube. Okay. Given potential energy, right here, given gravitational potential energy, that is U equals to gm by, how much is given? Let me say this, m alpha by r cube. Okay, m alpha divided by r cube. This much is the energy given. We know that a relation between force and potential energy, F equals to minus du by dr. We need to differentiate this. We will get a force, and gravitational force plus whatever the force we have calculated, sum of these two forces equals to mv square by r. Here I told that question is very lengthy. So F equals to minus d by dr of potential energy value is m alpha by r cube, m into alpha divided by r cube. Whatever the constants are there, write all those constants outside. Minus m into alpha is a constant, and d by dr of r cube, how much it is? R power minus 3, so that minus 3 comes here, and this becomes r power minus 4, so that we can write directly r to the power of 4. Here differentiation I have applied nothing. So minus of minus becomes plus. So this becomes 3m alpha divided by r to the power of 4. This is the force acting. Additional force. This is additional force due to given gravitational potential energy, or gravitational potential field also you can write. Okay, this is the total force acting. Now if I again redraw the diagram according to the given concept, so this is particle, mass is m, and another small particle is revolving around the circular orbit. How many forces are acting on the particle? One is gravitational force acting, plus another one is the additional force. Additional force is acting because of gravitation potential energy they have given. So these two forces together producing centripetal force for the particle, which helps in revolving in the circular orbit. So that the equation can be written this time as gravitational force plus additional force equals to mv square divided by r. Here also r not only we need to take, because this is the additional force where we are calculating this everything at r naught distance only. There is no change in radius, so r naught should be r naught only. There is no difference in that. So gravitational force formula, it will not be changed, same, G into capital M into small m divided by r naught square, plus what is the additional force we got? 3m into alpha divided by r to the power of 4 equals to mv square divided by r naught. Anything we can cancel here in this term, so left side small m, and here m gets cancelled. Take left side small m common, so that cancel. So what left here? Again we will write this everything as gm by r naught square plus 3 alpha divided by r to the power of 4 equals to v value, v equals to r omega, that is r naught square omega square, because v equals to r omega, v square is there, so r naught square omega square divided by r naught. Again cancel the terms here. We can cancel the terms, whatever the terms we can cancel here, make them cancel. R naught value, this here one square gets cancelled both, so that the equation becomes gm divided by, here r naught left in the numerator, r naught is there, I multiply here, so this is r naught cube plus 3 alpha divided by, well, this is also r naught, everything r naught only, divided by r naught to the power of 5 equals to omega square. Again omega square means what we can write, time period we need to relate, so time period can be written as 2 pi by t. Oh, we'll shift this one also down. The questions are so lengthy, we can't. I will shift it down. Chalo. Okay. Omega square. Now again rewrite this everything as omega square I am writing as 2 pi by t. 2 pi by t means again 4 pi square 2 pi. Omega can be written as 2 pi by t whole square. That means 4 pi square divided by, this time I am taking as t1 square. In the question they said that whenever the additional force is acting, what is the time period? So time period given as t1 square. Clear? Wait, here time ends or what, something it is showing. No, not time ends. Right, 4 pi t1 square equals to gm divided by r naught cube plus 3 alpha divided by r naught power 5. t1 square value we want, so that I will do one thing, we need to relate with that r naught. I will take common here, 4 pi square by t1 square equals to 1 by r naught cube I will take as common, so that we left with gm plus 3 alpha divided by r naught square. Okay, t1 square equals to, we want to write t1 square, cross multiply, so 4 pi square r naught cube whole divided by gm plus 3 alpha divided by r naught square. Okay. Now anything we can take common again here in this? Yes, I will take common here again. What I will take common is t1 square equals to 4 pi square r naught cube by, I'll take gm as common in the denominator, right? A root is there. Gm if I take common, so 1 plus 3 alpha by r naught square into gm. Understand what I have done? Gm I have taken common in the denominator, so that is the leftover equation. So cross multiply here, so that t1 equals to, total square root comes here, total will come as a square root of 4 pi square r naught cube divided by gm into 1 plus 3 alpha by r naught square into gm. Now we need to relate this t1 with t naught. How to relate this t1 with t naught? See, t naught means how much we got. We'll just copy this t naught. This is t naught value. So everything I will copy and I will paste here. This side I will paste here t1 value, so that we can compare whatever, we can compare the terms here. If you see this term here, 4 pi square r naught cube by gm, 4 pi square r naught cube divided by gm, square root of 4 pi square r naught cube by gm means what we can replace. I have simplified like this only because to relate with t naught. Sir, why we have to relate t1 and t naught? In the question they are asking that only, na? T naught and t1 we need to relate. That is why this entire calculations we have to do. See the question. See, t1 square minus t naught square divided by t1 square. So we have to relate t1 and t2. That's why we need to do this entire calculation. Very lengthy calculation. Beginning only I told, very tough only. In the actual exam, in the actual JEE advanced exam, if you see these questions, better you hold it. Okay, don't go immediately to solve these questions. Just hold it and go for the rest of the questions. These type of questions at the end only you have to attempt if time is there. In the beginning only if you attempt these questions, you are gone. You cannot solve rest of the question. Even though you do just a simple mistake, then again going back, verification, all the process what you have done is a very tough task. It's a highly impossible. So these type of questions, if you see, if you get the idea, actually it is a lengthy question, better you hold on it. Check it. See this, very lengthy. Now compare. So t1 equals to, instead of this under root 4 pi square r naught cube by gm, I just simply write t naught. What left here? Root over 1 plus 3 alpha divided by r naught square into gm. Now we got both the required equations. So this is a t naught value and here it is t1 value. At the end we got t1 value here. Now here t naught we know, t1 we know. Now everything is over. Let's just 3-4 steps are there calculation that I will give as a homework. What are those 3 steps here? Nothing but, see this one. They're asking T1 square minus T0 square by T1 square is how much? Already I know this every question already solved questions only, so that you will get answer as A 3 alpha by gm r0 square you will get, but you don't blindly follow it, you simplify by yourself. Everything I have done, T1 value, T0 value we got, substitute in the given condition. T1 square minus T0 square, condition is T1 square minus T0 square divided by T1 square. You simplify this equation so that you will get the final answer. Everything is given. T1 we got, T2 we got, T1 we got, T0 we got. Substitute in the given condition, you will get the final answer. Okay? This is the entire question. Very good quality question. 2-3 times. You please practice this. Never afraid of tough questions. Attempt tough questions only. Don't solve 30-40 easy questions. Solve 4-5 questions only. But take the very good quality of questions which build your thought process. Solving easy questions, nothing. You feel that answer today I have solved 30-40 questions, but nothing, no use. Solve 5 questions, 6 questions, 10 questions, very quality questions, and the questions should build your thought process. Then only there is a use. Okay. Next question is, this is 2024 advanced question. Next one is, this is 2025 advanced, this year question. It is also a good quality question only. See this question. A geostationary satellite above the equator is orbiting around the Earth at a fixed distance r1 from the center of the Earth. Okay. A second satellite is orbiting in the equatorial plane in the opposite direction to the Earth's rotation. Actually, direction is what? Opposite. Opposite direction. Okay. At a distance r2 from the center of the Earth, such that r1 equals to 1.21 r2. I hope every student, just by the time of reading this question, you may get some idea. Radius given, time period they are asking. I repeat, radius given, time period. Time period and radius, which formula relates? Only one equation. What is that? You can use either t equals to 2 pi r divided by v. That is also, but that is even more lengthy and tough. So Kepler's law is the best one to solve this question. Kepler's law, you can use Kepler's third law. The time period of the second satellite as measured from the geostationary satellite is 24 by p hours. You see here, time period of the second satellite as measured from the geostationary satellite is this much, 24 by p hours. Means what? Time period of satellite with respect to geostationary satellite. Relative time period. Each word is important. Relative time period value they have given. The value of P is how much they are asking. Okay. First to proceed the question with whatever the data you know. Let us take, there are 2 planets. Okay. Let us take, there are 2 planets. This is first planet orbit and this is the second planet orbit. 2 planets are there. Okay, they are revolving. Let me read about what they are revolving. As geostationary satellite above the equator. Okay, about the equator is orbiting around the Earth. Okay, they are rotating about, revolving around Earth only. Okay, this is center. Let us take from here to here. So radius I am taking as r1. r1 is greater than r2 they said. r1 is greater than r2 they said in the question. How they said? Because r1 equals to 1.21 times of r2. r1 equals to 1.21 times of r2. Fine, this is given data. So r1 value, this is geostationary satellite here. GSS satellite, geostationary satellite. And a planet is also rotating. Where is the planet? Planet is revolving center. A second satellite is orbiting in the equatorial plane in the opposite direction to that of the Earth rotation. Okay, let us take this geostationary satellite is revolving in this direction. This is the direction of geostationary satellite, and in the opposite direction another satellite is revolving in the opposite direction. This is the direction of velocity. Let's take its velocity is v2 and its velocity I will take as v1. Okay. Geostationary satellite is revolving and another planet means another satellite is revolving in the opposite direction. Okay, ratio of radius they have given, or else a relation between radius also they have given. Now time period. Geostationary satellite means what? Time period of geostationary satellite is equals to that of time period of the Earth. That's the meaning of geostationary. So relation between time periods and radius is square of time period is directly proportional to cube of the radius. This we know already. So t square equals to k into r cube, where k is a constant. You can take according to Kepler's third law. I have taken this equation. Now I will write here time periods. Two planets are there, means two satellites are there. One is having time period t1, second one is having time period t2 I am taking. So t1 by t2 whole square equals to r1 by r2 whole square. Here r1 by r2 whole square. So if I substitute whatever the required values are there, if I substitute those values, what is the answer we'll get here? T1 value is 24 only. I'll keep T1 as T1 by to change. This is what I have written here. Power cube, this is right. Power is 3. Okay. Now T1 divided by T2 whole square equals to R1 value given 1.21 times of R2 whole divided by R2 whole power 3. So R2 value gets cancelled here. These two cancel. So T1 by T2 whole square equals to 1.21 whole cube. Now from this we will write T1 by T2. How to write only T1 by T2 value? So T1 by T2 can be written as 1.21 whole power 3 by 2 I will write. Square I have removed so that here division came. So T2, so T2 equals to T1 divided by 1.21 whole power 3 divided by 2. This is T2 value. Here T2 value we got. Now if you know T2 value, T1 value we know. Relative time period they are asking. Relative time period means how to relate these two time periods. Just think, both the satellites are revolving around the Earth. They are revolving means they have linear velocity, they have angular velocity also. Angular velocity, if you consider omega, you can relate angular velocity with the time period. So angular velocity means 2 pi by t you can take. So take that formula, omega equals to 2 pi by t. But here directions, which direction both are rotating? Opposite directions both are rotating. So that relative angular velocity. Sir, why relative angular velocity? They are asking in the question relative time period. So to calculate relative time period, we are finding relative angular velocity. If you know relative angular velocity equation is 2 pi by t. Simple. If you know omega value, time period you can calculate. So this is the thought you have to get. Right. So relative angular velocity. So omega relative equals to, So relative velocity of satellite with respect to geostationary satellite, that is omega 2 minus of minus omega 1. Why minus of minus? Because both are rotating opposite. Na? Actual relative velocity means we have to subtract, but one is rotating opposite direction. So minus of minus omega 1. So omega relative becomes omega 2 plus omega 1. What is omega general equation? Just now I have written. So this is the general equation for omega. Omega equals to 2 pi by t. This equation we know. Let's substitute that equation here. So omega means 2 pi divided by time relative time equals to omega 2 means what? 2 pi by t2 plus omega 1 means 2 pi by t1. Here we can cancel this 2 pi gets cancelled. So t relative we want. So 1 divided by t relative equals to 1 by t2 plus 1 by t1. So that this equation becomes t1 t2 and t1 plus t, just cross multiply. So that t relative equals to t1 t2 divided by t1 plus t2. This is the relative time period. What is the t1 value? We know. What is the t2 value? We know. Just to substitute both here. T1 value I am taking as t1 only. T2 value. How to write a t2 value? That is t1 divided by 1.21 whole power 3 by 2. T1 divided by 1.31 whole to the power of 3 by 2 whole divided by t1 plus t2. So t1 plus t2 means t1 divided by 1.31 whole power 3 divided by 2. You just simplify this equation, you will get the answer for t relative. Because in the question they are asking t relative only, so that we can calculate t relative. Everything I have explained, you just the simplifications you do it. You can take t1 common also, so that t1 gets cancelled, you can do, right? Simplification, I hope you can do this. So these are all advanced questions of gravitation chapter what we have discussed. And in tomorrow's class or next week, whenever I get free time, so that I will record the lectures. It takes time. I need to arrange the questions. Okay, I need to explain in detail. So it takes time. So maybe next week. But one thing I can say that entire your 11th class, whatever the chapters are there, almost all advanced questions of all the chapters, I try to record and I will post. Whenever you get free time, you also just go through the lectures. One thing you have to remember, before you are watching these lectures, please revise your class notes again and again. I am telling, because you will forget all the formulas, important concepts, formulas required for solving these questions. Otherwise, it's very difficult to understand. Okay, so that's why just revise the entire notes once, then only you watch all these lectures. Try the questions. Clear? Maybe you will not get immediately solving skills, but gradually your skills will be improved. Okay, don't have any afraid thing, disappointing, demotivating yourselves, all those, never. Only one attitude you should have, learning attitude. That's it. Okay, take care. Bye bye.